Hi guys, and welcome to Lecture 5 of the Intro to Backend course. Today we'll be talking about containerization. But before we get into that, let's review what we talked about last week. So ORM is just using objects to interact with a database. So instead of just having tables and interacting with data as rows, we interact with data as objects. So each row is an object and each column is like a field. So if you recall in our demo video, we would say object dot column would be how you access that column instead of select star or select columns for these values, etc. This is really nice because it automatically handles enforcing reference conditions and manipulating join tables. So it's good for abstraction. And speaking of abstraction, we also went over what the data access object was. So this is just another layer of abstraction that lets us separate dealing with code that, unwraps the client post body versus interacting with the database. So it's nice in terms of making your code cleaner, and it's a lot more scalable if you want to, swap out an implementation. For example, you don't want to use this type of database in implementation anymore. You can totally switch it out, and having this layer makes it cleaner for you to do so. So now let's get into the topic of this lecture, which is how do we run apps on other machines? And something very important if you're going to be a backend developer is working with environments. So the number one thing that you need to set up when you're working on a project is environment variables. So your application could have some sensitive information like username and password combos, API keys. An example could be I only want certain people to access my Slack app, and I have a list of Slack usernames that I'm going to allow them to use this application, just as an example. And some sensitive information could just be those Slack usernames, and you want to be able to define them in a separate file that isn't seen by, people using your application or even seen on your GitHub repository. So this should be get ignored if you're developing with this. And the same .env file is also created on a remote server that you're hosting your application on, so that, whatever you're running on your server, the server also knows to go into that file and take whatever sensitive information that's needed to run the application. So this also leads us to talk about the virtual environment. So there's two main ideas to this whole environment section. So there's environment variables, and then there's also like packages and dependencies. So this is what we're talking about now. If you guys have been struggling with Virtualenv, that's totally fine. It's kind of hard to wrap your head around it, but essentially, if you've installed Virtualenv and worked with it, it's just some folder that you can activate and isolate all the packages and dependencies that you need for a project. You can deactivate it whenever you're not working on that project, so that, different versions of packages like Python 3 versus Python 2.7, that doesn't come in the way of you developing your project. So to give an example, let's say you have project A and project B. Both of these projects use the package requests, but let's say you started project A like a year ago and you're still working on it, but the version that you started off with developing project A was a much earlier version. But how do we work on project B without breaking project A? Because, you're going to have two requests installed. Which one does your computer know to use when you're developing a project? And so that's why you need this Virtualenv to isolate different environments that you can activate for when you're working on a certain project. So on a small scale approach, you would just install Python, install requirements.txt, just whatever file that, maybe a colleague you're working on with the project gave you because they've already started working on the project and these are the packages they've been needing or using to run the application. And then now that you have all your dependencies and libraries all set to go, you can run your application. So this workflow is completely fine for simple and small scale applications. But if we look at larger applications, however, this could include like a massive database. You might have, special package installations, and this would require you to manually isolate environments. Setup can be extremely cumbersome. If you look at larger scale applications, it's not just Python and Flask and requests. It could be a bajillion packages that you need to manage. So we want a modular and automated solution. So virtualization, we can talk about the old way. So this is basically just virtual machines, and how this works is you run a computer within a computer. So just as an example, I wanted to be able to use some software that was only available on a Windows computer, but I had a Mac. So I installed a virtual machine on my Mac, which let me run Windows on my Mac hardware. It was like really slow. And the reason for this is that you're basically allocating a completely new operating system on the space of your computer. Resources aren't shared. So in other words, this means that whatever you do on your Mac or your Windows VM, they're sandboxed from each other. So just to give you an idea, if you open like command prompt on Windows and you wanted to copy a command over to your Mac terminal, that's not possible. Clipboards aren't even shared. So it can be also just really annoying. And I'm sure some of you guys who, if you're taking like the iOS course and you're having a VM just to use Xcode, you can probably tell that it's very bulky and slow and just annoying. But this is how it would look like. So virtual machine for each app, and it's like a whole new operating system per app. Nothing is shared, and as you can tell, it might be a bit, cumbersome. And we'll go over a solution that we're going to be working with in this class. So let's talk about the deployment process. This is divided up into 4 steps. So first, compressing code into a production environment, and then preparing that production environment to be run ready. And then 3 and 4 are going to be covered in our next lecture. But these are, setting up your servers, getting them up and running, and then downloading whatever you prepared in steps 1 and 2 so that it can be run on your server. And we'll talk about why 1 and 2 are so important, but together, this is the idea of containerization. So like I said before, this is compressing code and preparing this environment. And the reason why we need to compress code is, like I said earlier in that VM, it can be very bulky, and Docker is our solution that can neatly package what we need to run our application on another computer. And the reason why we want to be able to run on another computer is because, right now your application only exists within the scope of your local laptop. But you don't want that. We want to be able to run our application on the web so that it's publicly accessible. And the way that you do that is, you buy a server on Google Cloud or Azure or AWS, and it allocates some server space for you so that you can download all the stuff that you need to run for your application, put it on that server, and let it run there. But before we can do all of that, we need to be able to package everything we need. So like put Python and Flask and requests in this like nice little package and build it with our application code. And having this run as a so-called container so that we can deploy our application. But we'll go more in depth into this. So a Docker image, you can think of it as like literally a picture. It's immutable, which means you can't change it. You can name it. If you want to quote unquote change it, you would just, build another image and rename the old name that you had before, because you can have tags. So it's kind of like if you think about making a commit to GitHub and it has like an identifier, like a commit hash, and in some ways you can give your Docker images that identifier, like a tag. So as an example, I work on Transit, and if we have a new version for backend rolling out, I'll name an image that I built like version 1.1.1, and then the next time I update something in the code, I want to build another image and I'll call it version 1.1.2. So that's just an idea of how you would interact with images, but it is defined with a Docker file. So it's literally a file called Docker file. It's case sensitive. There's no file extension, I believe, but it acts like a text file. You have some keys and values. Keys could be like the whatever things you need to run for your application, and values could be like, install it in this directory, install this package, so and so in this manner. And then once you've declared all those instructions in this Docker file, you would go to the directory where you define this Docker file and call docker build dot, which dot just means current directory. And Docker, assuming that you've installed Docker, will look at Docker file and build this, packaged application that includes everything you need and the code itself. But the next very important thing are Docker containers. So these are basically live instances of your app. So it's like running versions of your image, and you can specify additional instructions with like flags. So that's just like you have a command, and at the very end you have like a dash whatever command at the end. But you can find more documentation about this on the Docker website, but for now you shouldn't have to worry about it. But a command that you would have to run to start up your container is docker run and that name of the image. So if you happen to build your image previously and call it PA4, you would run it with this command. And so I think it's a lot easier to conceptualize what these two things are if you make them into analogies and compare them with tangible things that you probably understand better. So images are to containers as classes are to objects. So classes are like those blueprints, that map of what you define something can be run as, and then objects are actually like the fruits of your blueprint labors. So just to give more examples, you have recipes and cakes, and to put this more explicitly, images are instructions, and containers are just productions of these instructions. So as I was mentioning earlier about how you have an OS or operating system VM for each application, it's quite annoying and bulky and not space efficient at all. Docker, on the other hand, will handle, allocating resources on your laptop so that they can be shared. And essentially using one operating system, and Docker will help you balance what you need, so that you can run all these different types of apps with all different types of environments required all on your one laptop, or you can move it over to your remote server. So like I mentioned, the benefits are that, this is just a better way of managing applications. You use less resources because you're not using double the Python or double the Flask. You can boot up applications faster, and in general, this is just simple and is a modular approach. So step 2 of that containerization process is preparing your production environment to be run ready. And what this means is, so earlier I mentioned that you've built your app and you can run it amazingly on your local laptop, but you need to be able to put it on a server so that, everyone in the world can see this amazing job that you've done. And how you do that is you host your image somewhere called Docker Hub. And so when you go into your remote server, that's how you can get the image. This will make a lot more sense after the next lecture, but for now, you can think of it as like pushing code to GitHub, as is pushing an image to Docker Hub. So it's how you can, it's like an emailing service. Like, I want to be able to put my image on a remote server. Let me quote unquote email it to my server. But how that actually works is, so the whole process is, okay, I create a Docker file, I build my image, and then I push my image to Docker Hub so that when I get onto my remote server, I can pull that image. And I notice I did add like a bunch of whales here, but that's to help you conceptualize that, okay, my server can have lots of different applications running. And the 3 whales on the left is showing a process of 1 whale or 1 application, and on the right, a server is just a place where you can deploy multiple images. So do note that an application can have multiple images. And what's important about this is you can use something called a Docker Compose file to help you define and run applications that need multiple containers. So what does this even mean? Let me give you an example of Ithaca Transit, for example. So you open the app, you put in, I want to go to Becker Hall doesn't exist, Becker Dining Room, and I'm currently on North because I hate North dining food, so let's go to West to eat. The transit app will give me a list of routes, how long a bus is delayed by. So if you look at this from a standpoint of application, there's so many things going on. So there's a map view, and so we have a server, or we have a container that is literally allocated just to handle what a map can look like for a user. And then we have a server or a container that helps us get how much a bus is delayed by, and then another container that computes the routes that will be required to get you from North Campus to West Campus. So an app can actually divvy up all of its features into separate containers. So if something goes wrong, you can pinpoint, okay, this Docker container isn't running. So I know for sure, like, TCAT, the buses aren't giving me the right times that their buses are getting delayed by. So you can go and debug that. So this is how, software developers organize their workflows and their applications. It's just good, practice. And the way that you would organize all of this, so many containers issues, is Docker Compose. And so this is not to be confused with the Docker file. The Docker file is a set of instructions needed to build your image, and a Docker Compose is a file that contains names of these multiple images that you will need, which will essentially be those multiple containers. And you'll define, okay, I want this container to be running at port 5000, this one to be running at port 3000, etc., etc. So this defines multiple services. But in the scope of this course, you will still need to create a Docker Compose, but you'll just have one container because our applications are not that complicated yet. So I have this nice visual of my good friend Docker Compose Octopus and my Docker image or container whales. So if you can see, this octopus has like multiple bricks in his multiple tentacles, and that's just to give you a visual of how I can have separate applications in each of my tentacles, but I can orchestrate all of them with one like nice ocean creature or marine creature, which is my Docker Compose Octopus. And in case you didn't know what these are, this is Python, I think that's Postgres, Flask, and React. So in general, it's nice to abstract different features of your applications into different containers. So that should give you an idea, or an intuition of what goes behind developers' work. So I know that was a lot, but this is a summary of what goes down when you want to get your application up and running. So first, you got to define that Docker file to specify how you can run your app. And then you can build your Docker image from that file you defined. And then you push the image to Docker Hub so that it can be accessible by any computer. And in our case, we want it to be accessible by a remote server that we get from the Google Cloud so that it can be publicly accessible. And then you define how to run your images in some Docker Compose file that will be on that remote server so that it's like an instruction for the server on how to run all of your images, all of your containers into that one application. So now onto the general idea of DevOps. I'm sure you guys have heard this term. It's very hot lately, I guess you could say. There's a lot of startups trying to streamline this space, but what it basically is just the idea or principle of wanting to ship software in a continuous manner. So first, you're gonna, of course, build your software, which is what we've been doing. You want to test it continuously. And then DevOps is just that intersection of writing code and testing. So that having like a loop of, okay, I'm going to write this method and then test that. And then to a grander scale of, okay, I'm going to make a version 1 and test that before I make a version 2 and release that. Instead of, writing the entirety of, for example, Facebook, since it was whatever from the early 2000s into what it is now, DevOps is like each couple months I'm going to release something and test it and stuff like that. And so the goal is because you want to be able to ship your software quickly and reliably, and we want to make this process seamless and easy. And here's just like a nice visual of always planning and creating and then releasing, monitoring for any issues that go wrong. And more often than not, security is also a concern in this process. So we don't talk too much about security in this course, but it's something good to read up on, and it's also quite important. So that concludes the lecture on containerization. Hopefully it was very informational, but be hyped for next week on deployment because we'll be talking about what even the heck is a server, what SSH is, which is just, authenticating yourself into a server so that you can do cool stuff on it, what is clustering and what is load balancing. You'll get to know that in the next lecture. So let us know as usual if you guys have any questions on Piazza, and good luck for this assignment.